Okay, so today we're going to talk about isosceles triangles and then equilateral triangles. So, two congruent sides are called the legs. So what we mean by that are these. These are our legs. We are on page 7. Okay, so those are the legs. Just like you have two legs that are in theory identical to each other, these two legs are identical to each other. The angle where the sides intersect, is called the vertex angle. That would be the top of the mountain, right there. So like the Grand Teton, way up there, that's your vertex angle. Okay. Now across from the vertex angle, directly across from it, is the third side of the triangle, and that is called the base. Okay. And just so you know, the picture that you're looking at very well could be turned upside down on a worksheet, and you would have to recognize that these are the two legs and the base is over there. So you need to be very mindful about the markings. And then finally, it says the angles along the base are called base angles. So that would be this one here and this one here. So those are our parts. Isosceles triangle theorem, and then our converse. So the theorem says that if two sides are congruent, then angles opposite are congruent. In other words, the two angles that sit along the base, those are going to be congruent if the legs are congruent. So let's write this down. If AB is congruent to BC, okay, then we can say that angle A is equal to angle B, which is equal to angle C. Okay. Oh, forgot my little congruency marks. Here we go. Congruent. Now that's our theorem. We're going from sides. I know. We're going from sides to angles. That would be our theorem. Now when we flip-flop that, we get the converse. Do y'all remember that? Converse, we've already dealt with that already for parallel and perpendicular lines. So the converse is kind of the flip-flop. So if two angles along the base are congruent, then opposite sides are congruent, right? Yeah? Okay, so if angle A is congruent to angle B, and that's congruent to angle C. In other words, if all of... yeah, I'm like really tired and totally made a mistake. Please go up here. Please mark that out. Angle 2 and 3. This is angle A. This is angle C. Those are the only two that are congruent. I'm so sorry.
It's okay, Mrs. Bailey. Everybody makes mistakes.
I'm so glad that you are. Okay. At least you guys have been listening to me. All right. If angle A and angle C are congruent, then, okay, AB is going to be congruent to BC. Okay, all fixed. Okay, really fast. Right here, before you ever work any questions, you need to label everything that you can. So the first thing that I see this, which means my triangle is isosceles. Because these are congruent sides, these base angles are also congruent. So this side over here is 68 degrees. How would I get the K in the top? How would I get this one? If these two lines are congruent, then these two angles are congruent. I just want to know how would I get the missing angle of a triangle?
Because they all have to add up to 180.
Okay, so what would you do?
Add 68 and 68 and subtract it from 180.
Okay.
Which is 136.
Could I write it like that?
Yeah.
Okay. And what is it?
68 plus 68 is 136, and 180 minus 136 is 44.
44. Does everybody agree with 44?
Yeah.
Okay, so I'm going to label this.
Really smart, so.
Okay. So do I have everything labeled on my triangle that I possibly can? I sure do. Now I can go answer it. Because guess what? Once you label it, now you have the answers. Nice and easy. I know. Okay, the next one. I'm going to turn it around so we can kind of see it in its regular habitat right there.
Isosceles.
It is isosceles because the legs.
And it's cute.
It was.
No, it's a 2.
Okay.
Special.
All right. Because the legs are congruent, then the base angles are congruent. How would you get these? 106 from 180. Okay. So let me show you this. Would this make sense to you? I have two X's. I don't know what they are. Would that make sense? What is 180 minus 106?
74.
Okay. And then if 74 equals the two X's, how do you get the X?
Divided by 2.
And you get?
37.
Okay. So if this is 37 and that's 37, great. I already know the number. I already know my answer. So make sure you label everything first. Okay, now this one over here, they want me to find a side and an angle. So let's label everything we can. I see this angle here is congruent to that angle there. Yeah?
Yep.
Okay, that means what kind of triangle is it? So I can put a mark here and a mark here. How much is that side over on the YZ?
Congruent to the other side.
It is congruent to the other side, so it would be 12, so I'd label that. How would I get this angle right up here?
Add the 2 angles and subtract it from 180.
Okay,
154.
all right, well what is 180 minus 154?
26.
26. Okay, do I have everything labeled?
Yeah.
Yeah, so YZ is the 12 and Y is the 26. Label everything before you answer the question. Okay, let's do number 4. Well, I take it back. Do you want me to do 4 or 5?
5.
Okay. I'm not doing both.
4,
6, 7.
5, 4.
Okay, let's raise our hand for 4.
Thanks for changing my mind.
Raise your hand for 5. Ooh, close.
No, she didn't raise her hand at all.
All right.
6 or 7.
Okay, we're going to do 5.
And 7.
So what do these markings tell me?
They're isosceles. It's congruent.
It's congruent. So what kind of triangle is it?
Isosceles.
And if it's isosceles, then what do I know about these angles?
They're the same.
They're the same. So that means equal. So 4x plus 7 equals 9x minus 33. Okay. Could I subtract the 9x first if I wanted?
Yeah, but I feel like it'd be easier if you didn't have negatives.
Agreed. Okay. All right. Now what do I do?
Add
37.
Minus 37.
33.
Am I adding or subtracting?
I'll say you messed me up, dude.
Okay. So what do we get? What's 33 plus 7? 40. 40 is equal to 5x. What do you do now? And what do you get? Okay. Did I find x?
Yes, ma'am.
Now, could I go find these angles?
Yes.
Which one do you like better?
Yes.
Okay. So 4 times 8 plus 7. How much is that angle? 31.
39.
Okay. If that one's 39, what's this one? Then this one is 39. And if both of those are 39, how do you get this top one?
You add together and you subtract it, or you subtract them by 1.
Okay, so what do you get?
102.
Here you get 102. Does it look like it makes sense?
Yeah.
That looks like an obtuse angle, right? Okay, have you noticed that I found everything out that I possibly could? Okay. All right, now, which one of these, I'm not doing both. Which one would you like?
6 or 7.
6, 7.
It's either 6 or 7.
7.
6.
Oh, 6.
Raise your hand for 6.
6.
Raise your hand for 7. Okay.
7.
Okay. What do we notice? Well, I notice I have 2 angles that are the same. So then what?
Isosceles.
Why is it isosceles?
Because the 2 angles are the same, which means both sides are the same.
Okay. So 9x minus 73 equals 3x plus 23. What do you want to do first? Okay, we're going to subtract the 3 first. So I get 6x minus 73 equals 23. What do you do now? What do we do right now? We're going to add 73. So 6x is
50.
What?
Wait.
96.
Oh, shoot. Wait, there.
96. What are we going to do now? Divide. And what do we get for x? 16. Now, that's just the x. What if I told you to go find the sides? Which one would you want to work?
3x plus 23.
Okay, so 3 times 7 plus 23.
Where the heck did we get 7 from?
Oh, the
X
page.
16.
The page number. I told y'all I was so tired. I wrote the page number in there.
Miss Bailey, what are you doing?
I'm trying not to fall asleep. Okay, what's 3 times 16?
It would be 48.
48 plus 23.
What?
48 plus 23.
72.
Does everybody agree?
Yes.
Okay, so if that one's side is 72, what should this one work out to be?
72.
It should. Somebody test it.
71, not 72.
Who said 72? It's 71?
Yeah.
Dude, who's that?
Wow. Okay, so 71. What should be over here then?
71.
Can you check it? Make sure.
Yeah.
All right, as long as they match, then you know you did it right.
Yes, ma'am.
Okay, let's go on to the next page.
I do. Why are you keep telling me to shut up, dude?
All right, let's talk right now about equilateral triangles. What does equilateral mean?
Equal sides.
equal sides. Okay, so a triangle is equilateral if and only if it is equiangular. What does equiangular mean?
Equal angles.
Equal angles. Okay. This is the easiest triangle to work with because if the measure of angle A, the measure of angle B, and the measure of angle C are all equivalent to each other, then AB equals BC equals CA. And what are the measure of angle A, B, and C? How'd you get it? How'd you get it? So 180 divided by 3 gives me the 60. 60 times 3 is 180. Every single equilateral triangle in the universe, all three angles are 60. You don't have to ever think about it. This is true. Now, if the sides are all the same, okay, so if the measures are the same of the angles, then the sides are the same. And if the sides are the same, then the angles are the same. Okay, now in this picture right here, I cannot do anything with the sides. Let me ask you this question though. I'm going to cover up the base. What does that kind of triangle look like? It looks like isosceles. I've got two congruent legs and two congruent base angles. Oh wait, what if I flip it this way? Cover up that base.
It also looks like an isosceles.
That looks like isosceles again. What if I turn it this way?
It still looks like it's
Okay, so let me tell you the secret. All equilateral triangles are isosceles. They are a special type of isosceles. Remember when we did linear pair and I said it's a special type of supplementary angles? Do y'all remember that? Linear pair is a special type. Well, equilateral is a special type of isosceles. Now, as per the previous page, these are not equilateral triangles. These are just isosceles, just regular, plain Jane, no frills. These are special. Okay, so let's do this again. We're going to label. Here's A, here's B. What do you know about C?
It's the same.
It's automatically 60 because 180 minus the 120 from the angles gives me 60. And then if that's 60, what else do I know?
All the sides are 9.
All the sides are the same, which means that would be 9 and that would be 9. Okay, do you see what I just did? This is work. This is the work that I would expect to see on your paper. That would be the minimum amount of work that I would like to see in your paper. Okay, let's go over here to this one. So now, the backwards. If all of the sides are the same, then what do we know?
60, 60, 60.
Okay, it is equilateral, which means it
All the
is,
sides are 24 centimeters.
it is 24 here, 24 here. What else do you know? Okay, angles are the same, and they're all what? Okay, so that's easy. Okay, now we're going to introduce some algebra into the mix. Yes. It's not. What do you notice in this triangle right here?
All the sides are the same, which means all the angles are 60.
Okay, all the sides are the same, which means all three angles, each one of them is 60 degrees. Here I have a little bit of algebra, and that angle is 60. What can you do to get x? 4x plus 8 is equal to 60. Now what do? Subtract your 8. 4x is equal to what?
52.
52. And when you divide by 4, what do you get? 13. Okay, over here, what do you notice? 60 is here, 60 is here. The last one would be 60, which means
Sides are the same.
all the sides are the same, which means
7x plus 19 equals 11x minus 8.
all right, what do you want to move first? Subtract what?
7x.
Okay, so minus 7x, minus 7x. 19 equals 4x minus 89. Now what do? Add 89. Okay, how much is that? 108 equals 4x. Now what do? And what do you get? So then x is equal to 27. Okay. You see this picture right here? I'm gonna walk you through this real quick. First of all, what do you notice about this? It's a triangle, right? And it is what? Inside a triangle, right? You see that right there? Okay. It says that it is isosceles. So ABC, that's the big one. So that side and that side are equal, which means angle 1 and angle 9 are equal. It says that DB and E is equilateral. So I'm going to put 2 marks here, 2 marks here, and I'll put 2 marks there. Which means that 5 and 4 and 6. Oh, 5, 4, and 6 are all 60? I can just come right over here and just go like this? Is that true? Oh, what else could you find automatically?
8.
Oh, I could find 8
And 3.
and 3.
And 2. Wait, no, you can't. No, not yet.
What are 8 and 3?
120.
Okay, so 3 is 120 and 8 is 120. Okay. Now, how would you get 1 and 9? Okay, yeah, you would do the algebra. 4x plus 3 equals 9x minus 47. What do you want to subtract first? Minus 4x minus 4x. 3 is equal to 5x minus 47. Now what do? Add 47. 50 equals 5x. What does x equal? 10. Is that the angle? No. Which one of these do you want to work with? Okay. 4 times 10 plus 3. 43. So what's angle 9? 43. All right, so angle 9 is 43. Angle 1 is 43. Now we only have 2 and 7. You what? Okay, well what is 120 plus 43?
163, which means 17.
180 minus 163 is 17. So how much is angle 7?
17.
How much is angle 2?
17.
Okay. All right. You guys have an assignment that you picked up today. Before you solve anything at all, I would probably go through and mark on the paper which ones are isosceles only and which ones are equilateral isosceles. And then as you work each question, label everything you can. Yeah? Okay. That is y'all's job today. Very good.